In this video, we're learning about derivatives of exponentials. An exponential usually looks like something to the power of x. And we may have learned about this very special number, e, in year 11. So basically, what happens when you do derivatives of exponentials is if you differentiate something like e to the x, it's going to be really good because the derivative is just e to the x. Really nice stuff. But if you try and differentiate a different function, like 2 to the x, you're going to get a really weird derivative. So you will get something like 2 to the x, but it's going to be multiplied by some horrible number out the front. And I can actually tell you what that number is. Turns out that number is log of 2. So yeah, 0.693. So you can see here, like, to actually work out the derivative of 2 to the x, it's a horrible number times 2 to the x. But when you work out the derivative of e to the x, it's nicely e to the x. A reason for that is because the log of e is 1. So in other words, this derivative here would be 1 times e to the x. And this is basically the definition of e, in a sense. So e to the x is the very special number such that when I have a function e to the x, the derivative matches the original function. If you have any number other than e, then you're going to get the derivative being almost the same, but you're timesing by this horrible number out the front. Just turns out that with e, that horrible number is 1. And e is this very special number, 2.718, and it goes on forever. It's kind of like pi in that sense. So you can do derivatives of e to the x. It's just e to the x. And if it's e to some function of x, that is actually the chain rule. So this thing down the bottom is an application of the chain rule. You get e to the function times the derivative of the function. In the past, we've called that the baby. All right, great. So let's see. Y equals 3e to the x, so dy dx. This is going to be, the 3 is just going to stay out the front, and you still get e to the x. Next one, f of x is that, f dash of x. So again, the 7 will stay out the front, and then you just differentiate the next bit, 5x to the 4. So you can still differentiate piece by piece here. Next one. So this next one is going to be our first application of this rule down the bottom here. So basically what happens with these is you're still going to get e to the power of all the same stuff. X to the 8 take 2x. That doesn't change at all. The only thing interesting that happens is you start timesing by the baby. So that's the derivative of the stuff up here. 8x7, take 2. Done. And you'll quite often see people write it out the front. So 8x7, take 2, times e to the power of x8, take 2x. Just a notation thing. Okay, differentiate this. Now, if you're feeling game, pause the video, stop, have a go at it. Now, hopefully you've had a go at it, and I'm hoping that you use the product rule. So that's something I didn't mention in the product rule video, but it's really important. The hard thing about the product rule is knowing when to use the product rule, because quite often it's hard to spot. So here u is x cubed, u dash is 3x squared, v is e to the x, and v dash is going to be e to the x. Just a straight up product rule. To y dx equals u dash v plus uv dash. And then that's going to be 3x squared times e to the x plus, u is x cubed times e to the x. Cool. So you'll often, trust me on this, you'll see later down the track that when we do derivatives that look like this, it's often really nice to pull out a common factor. So let's think about what common factors I have. I have x in common. In fact, I have x squared in common. So let's pull that out. I also have e to the x in common on both these terms. So if we look at that first term, the only thing that's left is 3. And then if we look at that second term, well, all that's left is just a singular x, because I've already taken out x squared. So really key point, both of those would be marked correct, but I want you to know how to get down to that bottom step for our next topic. All right, last one we'll do is a quotient rule, because we've got a fraction. So the top of the fraction is u and the bottom is v. All right, so u dash equals e to the x and v dash equals 2x. So we'll put it all in. F dash of x, according to the quotient rule, u dash v, take uv dash over v squared. All right. So that's going to be e to the x times x squared, take e to the x times 2x, all over v squared, v being x squared. So again, if I want on the top, I could pull out a factor of x and e to the x, e to the x. What am I left with? Well, I'm left with x, take away 2 over x. Well, x squared squared would be x to the 4. Nice little thing you can do here is cancel off that x with one of the ones down here. And then that simplifies us down a lot more. So you get e to the x, x take 2 over x cubed. Now, really key point, when the exam question asks you that answer is fine. It's just when we're doing the next topic, you'll want to know how to get down to these points here. So all these three would be considered correct, but I want you to know how to get to the bottom.